Have you ever tried to have a conversation where you had to hold the entire text of Don Quixote, the unabridged version of War and Peace, and literally every single script from all 8 stickers of Game of Thrones in your head at the exact same time?
I mean, that sounds less like a conversation and more like a guaranteed way to just, trigger a massive migraine.
Right. And well, for a human, it's completely impossible. But honestly, until very recently, for artificial intelligence, it was also a guaranteed way to crash the system.
Yeah, standard models would just freeze.
Exactly. If you tried feeding that massive mountain of text into a standard AI, it would either completely lock up on you or politely ask for summary or, just charge you an absolute fortune in computing fees before giving up.
Which is why today's topic is so fascinating.
It is. Welcome to this deep dive, by the way. Our mission today for you listening is to figure out if the sheer hype surrounding this new AI model, DeepSeek V4, is actually justified.
We want to know if this thing is the perfect storm of software innovation or just a 1.6 trillion parameter mirage.
Yeah, exactly. And to get to the bottom of that, we've pulled data from everywhere. We've got the actual DeepSeek technical papers, which are incredibly dense, plus insights from the Hugging Face developer community, 36KR, Mint, Yahoo Tech, Doe News, and Keeley Technology.
So we've done the heavy lifting to give you the insights you need without, drowning you in the raw code.
Because the core claim here is genuinely mind-bending. DeepSeek V4 can swallow 1 million tokens in a single prompt.
Which is just a massive number.
It really is. For those keeping track at home, that translates to roughly 750,000 words. So all those books and scripts I just mentioned, it can read them instantly.
Instantly. And the stakes here are astronomical.
Right, because this model isn't locked behind some massive corporate paywall. It's open source.
And it is roughly 50 times cheaper to use than its closest elite rivals.
50 times. And perhaps most dramatically, the sources say it is reportedly causing the CEO of NVIDIA to lose a lot of sleep.
Yeah, the real story of DeepSeek V4 isn't just about the sheer size of the model. I mean,
Right.
having a 1 million token window is impressive, sure.
But
But the monumental breakthrough is how it handles that staggering amount of data without instantly melting the servers it runs on.
right, the electric bill.
Exactly. When you look closely at the underlying architecture, this is ultimately a story about brilliant algorithms beating brute force hardware.
Well, let's pop the hood on that architecture because, anyone can slap a 1 million token sticker on a piece of software.
Oh, totally.
But the reality is the compute. It's the sheer power required to actually process that much information. And that brings us to their first massive innovation, something called mixture of experts, or MOE.
Oh, yeah.
Yeah.
Now, the sources note that DeepSeek V4 is a 1.6 trillion parameter model.
First, let's just ground that for a second. When we say parameters, we're basically talking about the artificial synapses in the AI's brain, right?
Right, the connections that hold all its knowledge.
And 1.6 trillion is a massive brain. But the trick here is that it only activates 49 billion of those parameters for any given query.
It doesn't fire up the whole brain for every single thought. Like, if you ask it to write a Python script, it doesn't need to boot up the part of its brain that speaks 16th century French poetry.
Oh, I like that. Think of it like this. Imagine having access to this colossal world-class library containing 1.6 million highly specialized books.
Okay, I'm picturing it.
But the librarian running the place is an absolute genius. When you walk in and ask a highly specific question, that librarian doesn't force you to read the entire building from floor to ceiling.
That would take forever.
Right, they instantly pull out the exact 49,000 books that are relevant to your specific question. So you get the combined knowledge of the entire library.
But you only pay the physical energy toll for reading a tiny targeted fraction of it.
Exactly.
And taking that librarian analogy a step further, the routing mechanism, like the way the librarian instantly knows which books to pull, is where the real magic happens.
Okay, tell me more about that.
Well, to understand why that energy toll is normally so punishing for AI, we really have to look at the traditional problem in this space. It's this huge bottleneck known as quadratic attention.
Quadratic attention. I mean, even the name just sounds computationally expensive.
It is incredibly expensive, both in server costs and raw electricity. In standard models, every time the AI generates a new word, it has to look back at every single previous word in the conversation.
To maintain the context, right?
Exactly. So if you have a 10-word sentence, it looks back 10 times. But if you have 750,000 words, a full million tokens, the map just grows exponentially.
Oh, wow. So it has to look back millions and millions of times for every single new syllable it spits out.
Yes, that requires immense computing power. It literally drains local power grids.
That's crazy.
But DeepSeek V4 bypasses this massive roadblock using two distinct software tricks.
Okay, what's the first trick? Let's break this down.
The first is called compressed sparse attention, or CSA.
CSA, got it.
Imagine you are trying to find one specific needle in an impossibly large haystack. CSA doesn't examine every single piece of hay. First, it compresses the data.
Compresses it how?
It takes every 4 words and squashes them down into one highly dense super token.
Hold on, squashing 4 words into one. If I'm reading a dense technical manual and I just skip every 4 words, I'm going to completely lose the plot.
Sure, yeah.
So how is this not just degrading the AI's intelligence to, save a buck?
It's a really vital question.
Mm-hmm.
But it's not skipping words. It's compressing them. Think of it like an acronym.
Okay.
Instead of saying National Aeronautics and Space Administration every single time, you just say NASA.
Ah, right.
The AI basically creates its own highly efficient mathematical acronyms to save space without losing the underlying meaning.
Okay, so it's speaking its own internal shorthand.
Yes, exactly.
Yeah.
But then it goes further. To find the answer in that shorthand, it uses something called a lightning indexer.
Sounds fast.
Very fast.
Cool.
This indexer runs in a math format known as FP4. Now, FP4 is a very low-resolution way for computers to do math.
Wait, low resolution?
Yeah, it's not trying to read the text perfectly. It's doing a rapid, blurry scan to instantly locate the 512 most promising blocks of data where the answer might hide.
I see. So if I'm trying to drive to New York City, I don't need a high-definition 4K satellite image of the entire East Coast just to get on the highway.
Exactly.
A blurry map gets me to the right state instantly, and then I can zoom in.
That is a perfect way to visualize it. It finds the general vicinity of the needle instantly using low-resolution math.
And then what?
Then the second trick kicks in, HCA, or heavily compressed attention.
Okay, so we had CSA, now we have HCA.
Right. While CSA is for finding the needle, HCA is for understanding the shape of the haystack itself.
The big picture.
Exactly. It compresses the overall document by an extreme factor of 128x.
128 times. That's wild.
It is. This allows the model to view the entire overarching context of the document incredibly cheaply, without getting bogged down in the minute details of the paragraphs it doesn't need right now.
So the AI community must have been highly skeptical of this, right?
Yeah.
Relying on blurry maps and extreme 128x compression sounds like a recipe for a model that just hallucinates constantly.
Oh, they were very skeptical. But the technical paper provides the hard, verifiable data.
And the data holds up.
It does. They aren't cutting corners on intelligence. They are optimizing memory caching to a degree we really haven't seen before. Let's look at the actual numbers.
Okay, hit me.
When processing a full 1 million tokens, the V4 Pro model uses only 27% of the computing power that its direct predecessor, the V3.2, required.
Wait, 27%? That's nearly a 75% reduction in power for the exact same task.
Yeah. And the memory cache, the temporary scratchpad memory the AI uses to hold your current conversation in its head, known as the KV cache.
Right.
That is reduced to an astonishing 10% of what it used to be.
That is just ridiculous.
And the smaller V4 Flash model drops those numbers even lower. They haven't just made the model bigger by throwing more parameters at it.
We've completely re-engineered the fundamental physics of how the AI actually reads. And when you change the physics of how an AI reads, you change the economics of the entire tech industry. Because energy efficiency isn't just about saving the planet or lowering the electric bill.
No, it fundamentally changes the business model of artificial intelligence.
Right. This software optimization has inadvertently created a massive geopolitical weapon.
Because in this industry, extreme efficiency directly translates to a total collapse in cost.
The cost difference here is an absolute bombshell. According to the data, the API for DeepSeek V4, meaning the price that independent developers pay to plug this intelligence into their own apps and websites,
Yes.
it costs about 50 times less than OpenAI's GPT 5.4. 50 times.
It's hard to even wrap your head around that scale of savings.
I mean, if you're a startup trying to build the next big app, your server costs just drop from thousands of dollars to like the price of a cup of coffee.
Which completely upends the moat that the massive tech monopolies have spent billions trying to build.
And it's making waves at the very top of the global food chain. Jensen Huang, the CEO of NVIDIA, the company that makes the physical microchips powering almost all the world's AI.
Right, the biggest player in the hardware space.
Exactly. He was quoted calling this development catastrophic. In some translations from the sources, the word was literally disastrous.
You really have to look at the foundations of NVIDIA's empire to understand why a hardware CEO is terrified of a software update.
Let's get into that, yeah.
NVIDIA is currently one of the most valuable companies on the planet. They are the ones selling the shovels in the AI gold rush.
Right.
But they don't just sell physical chips of silicon. They sell a software monopoly called CUD.
Okay, let's break CUA down for a second because this is kind of the invisible engine of the whole AI war.
It really is.
Yeah.
CUD is essentially the operating system, the programming platform, that allows AI software to talk to NVIDIA hardware.
Okay.
For years, the industry consensus was absolute. If you wanted to build an elite AI, you had to use NVIDIA chips because you absolutely had to use CUD. It was an impenetrable moat.
So you were locked into their ecosystem. If you didn't pay the NVIDIA toll road, you simply didn't play in the big leagues.
Precisely. But DeepSeek achieved all of this. The 1 million tokens, the massive efficiency, the 1.6 trillion parameters,
Yeah.
while training and inferencing on Huawei Ascendant PUs, they completely bypassed NVIDIA chips.
Wow.
They proved that an open-source model can run on Huawei's CAN-N ecosystem, which is their alternative to CUDA, with near-native performance.
So they basically built their own off-road vehicle to bypass the toll road entirely.
Yes. And the benchmarks published showed that specific adaptations to the Huawei Ascend architecture actually yielded accelerations of up to 1.73x.
So it's not even a compromise.
No, they aren't just surviving on alternative hardware. They are thriving on it.
That's incredible.
And if we synthesize what this means geopolitically, we live in a world of intense, heavily enforced hardware sanctions. The most advanced NVIDIA chips are highly restricted globally.
Right. Certain countries just can't buy them.
Exactly. DeepSeek just proved to the entire world that brilliant software innovation can bypass the need for the most expensive, restricted hardware. It is the ultimate workaround.
Okay, so if V4 is bypassing hardware sanctions, dropping costs by a factor of 50, and terrifying tech CEOs, it feels like it should be taking over the world right now.
You would think so?
But all of this optimization means absolutely nothing if the output is garbage. I mean, a cheap, highly efficient car that drives you directly into a ditch is still a bad car.
That is very true.
So let's look at the report card for you listening. Is this thing actually smart? Let's dive into the performance benchmarks.
The benchmarks are where the theoretical efficiency meets the harsh reality of human expectations. And the numbers in these sources are highly disruptive.
Let's start with coding, because that's a massive use case for AI right now.
Huge use case.
On Codeforces, which is a highly competitive global programming platform where humans solve complex algorithms, the V4 Pro Max model hit a rating of 3D Neo 6.
Which is an incredible score.
Right, and to put that number in perspective for the listener, that places this AI at roughly 23rd in the global human rankings.
23rd in the world.
Out of all the competitive human programmers on Earth, this software sits in the top 25. It is operating at an elite grandmaster level in logic and syntax.
It is functionally better at writing code than almost every human alive.
Then there's hard math. They ran it through the Putnam 2025 math competition.
Oh, the Putnam.
Yeah, and this isn't high school algebra or some standardized test. This is notoriously brutal college-level mathematics. DeepSeek V4 scored a perfect 120 out of 120.
And we really have to pause on that 120 score.
Why is that so significant?
Because AI models, large language models, are fundamentally just predicting the next most likely word. They are not calculators.
Right, they just guess what comes next.
Exactly. So they historically struggle with complex math because they don't natively reason through multi-step logic.
Oh, that makes sense.
So scoring a perfect 120 on the Putnam means the model has achieved a level of deep multi-step reasoning that was previously thought to be years away.
Wow. And then we have agent tasks. They use Terminal Bench 2.0. This benchmark basically measures how well the AI can use tools, navigate a computer's operating system, and act like an autonomous human assistant.
Very important for real-world use.
Yeah. It scored 67.9, which decisively beats out major regional competitors like GLM 5.1 and Kimi. So, looking at these numbers, top 25 global coder, flawless advanced math, autonomous tool use. Is this the undisputed king of everything? Have we reached the peak of the mountain?
That is where the data demands some nuance because the short answer is no.
Okay, what's the catch?
It is a titan in pure reasoning, mathematics, and coding, but it still lags behind some of the established elite models in a few key areas.
Like where?
Well, you mentioned that 67.9 score in agent tasks. That is a strong score. But OpenAI's GPT 5.4 X High still beats it significantly in that specific benchmark, scoring a 75.1.
Okay.
So for complex, multi-tool human emulation, OpenAI still holds an edge.
What about everyday knowledge? Like if I just want to ask a random facts.
When you look at general knowledge in trivia, which is measured by benchmarks like Simple QA Google's, Gemini still consistently comes out on top.
Okay, so to directly connect this for you listening, it's really all about choosing the right tool for the job.
Absolutely.
If you are a software developer, a data scientist, or you just need pure, unadulterated, complex problem solving, V4 is incredibly compelling.
Unbeatable in some ways.
But if you want an AI to act as a general trivia bot, or flawlessly execute a complex chain of administrative tasks across 5 different apps, you might still lean toward the established Western giant.
But even if it was the undisputed king of every benchmark, we have to look at the reality of deployment.
Right, getting it into people's hands.
Scaling a model like this globally brings immense real-world friction.
Because a high IQ doesn't mean much if the server crashes before it can answer your question. Let's talk about the physical bottlenecks they are facing right now.
The sheer popularity of the model is currently its biggest vulnerability.
It's too popular.
V4 Pro is so cheap and so capable that the demand from developers is absolutely off the charts.
Yeah, the sources are very clear on this. They simply cannot keep up with the throughput capacity. The servers are acting as a massive bottleneck.
People are logging on, submitting their prompts, and just getting timeout errors.
It's the classic victim of its own viral success. But there's a longer-term issue mentioned in the sources that speaks to the future of the company itself. It's a question of human capital.
Yes, the talent drain.
What's happening there?
Well, DeepSeek didn't build this model in a vacuum. It builds upon their previous breakthrough models, R1 and V3. But key figures, the rare, brilliant minds who architected those foundational models and actually figured out these compression tricks.
Right, the geniuses behind the curtain.
Exactly. They have recently left DeepSeek. They've been poached by massive tech giants like ByteDance, Tencent, and Xiaomi.
Oof. Which raises a massive red flag for the future. I mean, can a company keep innovating at this breakneck pace if the original brains behind the operation have left the building?
It's a huge question mark. AI isn't just about raw compute power. It's about the individuals who know how to manipulate the math.
All right.
And that leads directly into a broader debate hovering over the entire AI community regarding those incredible benchmark scores we just discussed.
Okay, what's the debate?
It's the concept of overfitting.
Oh, I've seen this term thrown around in the developer forums. This is the idea that maybe the AI isn't actually a genius. Maybe it's just memorized the answers to the test.
Essentially, yes.
Yeah.
Think of a student who spends all year taking practice SATs.
Okay.
They might score a perfect 1600 on test day. But if you put them in a real-world office and ask them to solve a novel problem, they completely freeze.
Right. They know the test, not the subject.
Exactly. The community is actively debating, is V4 actually this capable in the unpredictable real world? Or has its architecture been specifically optimized to beat these exact benchmarks?
Like those compression tricks we talked about, CSA and HCA. Squashing the words to find the needle in the haystack.
Yes, exactly. Those tricks are undeniably brilliant for a standardized needle in a haystack test.
Sure.
But does that extreme compression perfectly translate to every type of messy, nuanced human interaction?
That's the million-dollar question.
Internal developer tests are reporting incredible real-world results. But the broader global open-source community is still in the process of rigorously verifying these claims over time.
So we're basically waiting to see how it performs in the wild outside of the pristine laboratory environment.
Yes.
And speaking of the real world, there's one more factor we have to address. Because DeepSeek V4 comes from China, there are natural questions raised in our sources regarding how the model handles politically sensitive topics or information control.
It is an unavoidable reality of global tech adoption right now.
And to be clear to you listening, we are simply reporting on the calculus that enterprise businesses are doing right now. We aren't taking a side or endorsing anything here.
Right. We're just conveying what the sources emphasize.
Exactly. While these specific guardrails aren't detailed in the technical mathematical papers we reviewed, the industry sources note that this origin is a vital trust factor.
It really is.
For Western enterprise users, data security, censorship, and the underlying guardrails of an AI model are major variables they have to weigh when deciding whether to integrate this intelligence into their core infrastructure.
It's a risk assessment every CTO has to make.
Yeah.
But despite the server bottlenecks, the talent drain, the ongoing tests for overfitting, and the geopolitical trust factors, the fundamental truth remains staggering.
The entire battlefield has changed.
Yes. The AI war is no longer solely about who has the deepest pockets or who can hoard the most expensive NVIDIA chips. DeepSeek V4 is an open-source rebellion.
It's licensed under MIT, which is incredibly permissive.
Which means any startup operating out of a garage anywhere in the world can download this architecture and build a global business on top of it without paying massive royalties to a tech monopoly.
It completely levels the playing field.
It really does.
Let's recap what we've discovered today. DeepSeek V4 is a 1.6 trillion parameter heavyweight, but it's a terrifyingly efficient heavyweight.
By utilizing clever compression techniques like CSA to find the specific data and HCA to view the broad context, it can read 1 million tokens with unprecedented energy efficiency.
It operates on alternative Chinese hardware, directly bypassing the NVIDIA C2A monopoly and neutralizing global hardware sanctions.
It dominates high-level coding and college-level math, operating at an elite human tier, even if you might want to use a different model for casual trivia.
And it's managing to do all of this while navigating massive server bottlenecks and very real questions about talent retention and enterprise trust.
So true.
The bottom line, the barrier to entry for elite world-class artificial intelligence just hit rock bottom.
And that leads to a rather provocative thought to leave on.
Oh, let's hear it.
We've seen today that DeepSeek's ultimate weapon was software efficiency. It essentially hacked its way around physical hardware limitations and international sanctions through brilliant algorithmic design.
Right, it was a human workaround.
Exactly. But as these AI models get progressively smarter, especially at coding and logic, what happens when open-source AI starts designing its own algorithm?
Oh, wow. We're talking about AI writing the next generation of AI.
Could a future model write code so flawlessly compressed, so mathematically perfect, that the physical silicon chips we fight over and sanction today become completely irrelevant?
That is wild.
We are entering an era where software might permanently outsmart the limitations of hardware.
The ultimate software eating the ultimate hardware. That is a massive paradigm-shifting thought to leave on. Think about that the next time you're staring at an AI text prompt. You aren't just looking at a chatbot. You're looking at a library of 1 million books, waiting for a librarian that never sleeps, running on an engine that is quietly rewriting the geopolitical rules of the world. Thank you for joining us on this deep dive. Keep questioning, keep exploring, and we'll see you next time.